Have you ever really stopped to think about what's happening inside your computer? I mean, we use these things every single day, right? But just beneath that glossy screen, there's this incredibly complex, totally invisible world at work. Today, we're going to pull back that curtain and look at the most important piece of software you own, your operating system.
It all kicks off with something so simple, something you do without even thinking. You double-click an icon to open up an app, and poof, it's there. It feels instant, but in that tiny split second, a whole chain of events just fired off. So what's the invisible force that takes your click and turns it into a running program?
Okay, so think of it like this. On one side, there's you, the user. On the other, there are all your apps. But right in the middle, there's this super important invisible manager that's running the whole show. For now, it's just a question mark, but that's exactly what we're going to uncover today. This is the operating system, the engine that makes everything else go.
All right, let's start peeling this onion back, one layer at a time. The very first layer is the one we all know and see. It's how we, as humans, tell the computer what we want it to do.
So there are basically two main ways we speak to our computers. Most of us use what's on the left, the graphical user interface. You know, the good old GUI. It's the familiar world of icons, windows, and menus you see in Mac OS and Windows. But then, on the right, you've got the command line interface, or CLI, like the Unix shell. It's all text, no pictures, but it is incredibly powerful and efficient, which is why developers absolutely love it. They look totally different, but they're really just two different doors into the same powerful system.
So that's how we get our message across to the operating system. But what about our programs? I mean, your web browser doesn't have a little mouse to click on icons. It needs a much more direct, more official way to communicate with the OS.
And that brings us to layer 2. Let's go a little deeper and check out this critical communication channel that exists between your apps and the core of the operating system.
This communication happens through something called a system call. You can think of it like an app formally requesting a service from the OS. It's almost like going to City Hall to get an official permit. A program can't just decide to create a file on its own. It has to ask the operating system for permission. And this isn't just about being polite. It's absolutely fundamental for keeping your computer stable and secure. The OS is the gatekeeper, making sure one bad app doesn't bring down the whole system.
And this is a perfect example of how it works. Let's say a program wants to copy a file. It doesn't just grab the data itself, no way. Instead, it makes a series of system calls. First, it asks the OS, hey, can you open this file for me? Then, it makes another call to create the new file. After that, it gets into a loop, repeatedly calling read and write to shuttle the data across. And when it's all done, it tells the OS to close both files. The app is like the project manager, but it's the OS that's doing all the heavy lifting through these essential services.
You know, this whole idea of system calls actually helps us answer a really common question. If all these programs are just making requests, why can't an app built for a Mac just run on a Windows machine?
Well, the simple answer is they're speaking completely different languages. Each operating system has its own unique set of system calls, its own special vocabulary of requests and permits. A Mac app is coded to ask for services from Mac OS, while a Windows app is built to use the Windows system. When you throw in different file formats and even different instructions for the computer's processor, you can see why they're so specific. They're like puzzle pieces that are only designed to fit in one particular puzzle.
Okay, so we've covered the user interface and the application interface. Now let's get even deeper. It's time to crack open the engine room and see how the operating system itself is actually put together.
This really highlights a huge choice in how you design an OS. On the left, you've got the monolithic structure. It's basically one giant interconnected program. The upside, it's ridiculously fast because all the parts can talk to each other directly. The downside, if one little thing breaks, it can be an absolute nightmare to find and fix. Then, on the right, you have the layered structure, which is much more organized, kind of like a stack of Legos. This makes it way easier to debug because you can pinpoint problems to a specific layer. The trade-off is that it can be a little slower, since requests have to travel up and down through all those layers.
And hey, this isn't just some abstract textbook idea. This layered approach is exactly how modern systems like Android and iOS are built. The phone you're probably holding right now runs on a layered stack of software. It's what gives developers such a rich, stable foundation to build all those amazing apps on top of.
So we've explored the OS from the outside in. For our final layer, let's rewind all the way back to the very, very beginning, to the spark of life. What is the first thing that happens when you hit that power button?
Well, that's the boot process, a critical startup sequence. The instant power hits the machine, a tiny program called the Bootstrap program wakes up. It lives on a special chip, so it's always there, ready to go. Its one job is to find the main OS kernel on your hard drive. Then, another program called a loader takes that kernel and carefully places it into your computer's main memory, the RAM. And once that kernel is loaded, it's in charge. It wakes up all your hardware, starts up essential services, and only when all of that is done does your login screen finally pop up.
Whew, okay. So, after peeling back all those layers, from the interface you see every day, to the system calls apps use, to the deep internal structure, and all the way back to the boot process, let's put it all back together. Remember that diagram from the beginning? The one with the big question mark in the middle? That invisible manager sitting between you and your apps? Well, now we can finally, confidently fill in that blank. It is, of course, the operating system. So the full journey of a single click is really just an incredible, high-speed conversation. Your click in the GUI kicks things off. The OS gets the message, and the program starts a rapid-fire series of system calls to the kernel, asking for everything it needs. The kernel, the ultimate manager, marshals the hardware, and in what feels like an instant, the app appears on your screen. It's this seamless, constant dialogue that makes it all work. At the end of the day, the operating system is this powerful, tireless manager working behind the scenes for you 24/7. So now that you've had a peek inside the engine room, I'm curious, what simple, everyday task like saving a file or opening a new browser tab are you going to see just a little bit differently?